Today, to factor a difference of two squares, a sum of two cubes, and a difference of two cubes. Flashcards. For the following slides, you have the following options. A difference of two squares, difference of two cubes, sum of two cubes, factorable, not factorable. On the first one here, what is this one?
Difference of two cubes. Squares.
A difference of two squares, and there is the work that goes with it. What is this one?
Factorable.
It's simply factorable. You can take out a 3 from both items, but that's all you can do. What's this one?
Not factorable.
Not factorable. Not factorable. And this one is a sum of two cubes. Yeah, it's the sum of two cubes. What is this one?
Factorable.
Yes, it is factorable. A difference of what? Difference of two cubes. Yeah. If you factor out the 5 here, there it is, looking for the pointer. If you factor out the 5, you're left with a difference of two cubes. So then you continue on to factor it out. What about this one? Not factorable. That one. Factorable, you can take out a 2. This one. Factorable, you can take out a 12, but when you do, you're left with x cubed minus 3, and 3 is not a perfect cube. What about this one? Difference of two cubes, and that's just the basic setup. What about this one? It is factorable. Difference of two squares, because the square root of the first one is 3x squared, and 5y to the third is the square root of 25y to the sixth. What about this one? It is factorable.
Difference of two squares.
A difference of two squares. It is a difference of two squares, and this is what you get when you break it up initially. But notice that the second one with the minus sign is also a difference of two squares. So you can even break that one up further. 2x squared plus 1, 2x squared minus 1. So you end up with 3 quantities on that one. What about this one?
Difference of two cubes.
Difference of two cubes, yeah. 4x to the third and 5x squared are the square roots, or are the cube roots. What about this one?
Not.
Factorable, you can take out a 3. What happens if I put a minus sign in there? It's a difference of two squares. What about this one? Not factorable. 3 is not a perfect square.
Sum of two cubes.
Sum of two cubes. And I put squares. I don't know why. But that should be cubes. What about this one?
Not factorable.
This one.
Sum of two cubes.
Sum of two cubes. What about this one?
Difference of two squares.
Difference of two squares, and on this one, when you break it up, notice that the second one becomes a difference of two squares as well. So you end up with three quantities, and this one comes from this one here. This one.
Squares.
Difference of two squares. Alright, practice number 1. Try this one and drop it off. On this one, it's a sum of two cubes, so you must start with x plus 2. Those are the cube roots of each of the terms. And now in the back half, you have a minus plus sign combination. Square this one, multiply these two, and then square that one. This is a difference of two cubes. The cube root of x to the sixth is x squared. If you can divide the exponent by 3, then that means it is a perfect cube. And then over here you have 5. Now on the back side you have a minus plus combination. Square this one. Oh yeah, you get plus plus. You get a plus plus combination. So you have x to the fourth, and then 5x squared, and then 25. Here is the solution. This is a difference of two squares. 25 is a perfect square, so is this one and the 1. So 5x plus 1, 5x minus 1. Alright, for this one you can factor out a 3. When you do that, you're left with x squared minus 36. 108 divided by 3 is 36. This is a difference of two squares. So x plus 6, x minus 6 in addition to this.